So the project was initially motivated by the benefits demonstrated in prior research, showing that VCSEL fabrication had the potential to be simplified and cost reduced by using self-alignment methods. And I've referenced a seminal publication on that technology at the bottom of the slide. Basically, in addition to that, given the market drivers and performance benefits of the 5G rollout, there's almost endless applications, it seems now, where this type of technology can apply. Since time to scale up advantage is very huge in the electronics industry, it seems logical to effectively extend the materials that are available for new products if possible. And the basis of this work really is born out of Stoney's formula, which describes the characteristics of a cantilever beam under stress. It's a very convenient model to apply to a bilayer structure owing to its characteristics. And as you can see here, the image to the left depicts a typical bilayer structure that's used in liftoff. You can associate the various structure variables such as resist thickness, undercut, and whatnot to specific variables in Stoney's formula, which you can see that I've provided off to the right. So basically, the deposition process and film material become the stress affecting the cantilever beam. The resist materials, as well as geometric dimensions selected, which are mostly adjustable in the case of a bilayer liftoff type design, which is something that's unique, can essentially guide you to a usable set of guideline design aspects for the structure being used for a given process and material set. And what's mostly novel about the work that we're presenting here is that aside from looking at sputtering, it's addressing insulator films. The conformal coatings are not normally the domain of a liftoff process because of their conformal nature, but in the case of a bilayer design, you can take into account for certain aspects of that type of deposition and material. Generally, bilayers are probably most popularly known for use with metallization schemes and more commonly evaporation type technologies.